Welcome to part 2 of Module 8. You're almost finished. In this part, we are talking about the adaptations that you could make within DBI. So we have two objectives in this part of the module. First, we're going to focus on the taxonomy of intervention adaptations, and I know you've probably seen some of this in another course related to DBI. And then I'm going to talk about common adaptations that we can use within DBI to help students when their response is not exactly where we would like it to be, or you might call that inadequate response. So where on earth are we? So here's our arrow, and here's our DBI diagram. And we have worked all the way down to this part here. So we started talking about the instructional platform. We've done a lot of work around progress monitoring. We talked about diagnostic assessments. But what do you do when students are non-responsive? We do that diagnostic, and then we need to adapt the intervention. And that's where we are today. We're thinking about ways to adapt the intervention that are going to be meaningful for students so that hopefully after we progress monitor for a while, we'll see response instead of non-response. Now, there's this whole idea that there's this taxonomy to intervention adaptations. I'm going to slide this over here to the left so I can show you some things over here. Remember, we start with this validated instructional platform. And then this is something that studies. We want to think of like how much does that program actually increase the academic needs of students. And in this part of in this module, or in this course, we're talking about mathematics, but this could also apply to reading as well. So we start with that validated intervention platform, and we need to make sure that we're implementing it with fidelity. We've already talked about fidelity and how important it is to implement the program as it's meant to be implemented. And then we determine whether students are responsive or non-responsive. And when students are non-responsive, we do that diagnostic, and that diagnostic helps us figure out, well, what are some of the reasons that the student might not be responding? What are the strengths and weaknesses of this student? And that is our focus, where we need to go back and fill in some of those weakness spots. Then we're going to adapt the intervention, which is what we're going to get into in just a few slides here. And this adaptation, we hope, will help the student increase their response to the instructional platform. And so what are some of the possibilities to this adaptation? So there's quite a few that are in this taxonomy, and we'll go over these on some of the next few slides. We'll talk about behavior supports. We'll talk about increasing the dosage that the students are receiving to the intensive intervention. We'll also talk about whether the program is really aligned with student needs and ways that we can finagle that to make it more accessible for the student. We'll talk about whether we're using explicit instruction and whether we're actually teaching for transfer. And once those adaptations are in place, then we progress monitor to see whether students are responsive or non-responsive. So I'm going to take this taxonomy of the adaptations. This is something that's been used across courses here with the NCII project, and I'm going to dig into it in terms of mathematics. So let's think about our instructional platform. So we've got our instructional platform here. We've got everything in place. We've done our diagnostic. We've scoped and sequenced. We've got our instructional platform. But when things are not working for students, when students are non-responsive, it is time to make an adaptation. So this helps us circle back to a reading that we read at the very beginning of this course about how to intensify mathematics intervention. We talked about adaptations. So let's see what some of those adaptations might be. I'm going to look at 6 of them today. One of the adaptations that we might be interested in is implementing the program with greater fidelity. You really need to make sure that you're implementing the program as it's meant to be implemented. Now, this might be an evidence-based strategy, such as cover, copy, compare. So are you actually doing cover, copy, compare as it is outlined? It could also be with an evidence-based intervention. For example, here's a fidelity checklist from an intervention. It's quite a bit more detailed than the outline for cover, copy, compare. But with this word problem intervention, are you actually doing all of the components? So these checklists help you make sure that you're implementing the program with strong fidelity. That might be an adaptation that you can make, and it's super easy. You just need to make sure that you're doing all of the components of the intervention. Now, another adaptation that you might consider is embedding behavioral supports. Oftentimes, students that have math difficulty also struggle with attention, and they may not be as focused on the mathematics as we would like them to be. So by embedding behavioral supports, we can let the student learn more mathematics. So some strategies that we may want to use are just like, here's like a little checklist, like every minute a timer beeps and is the student on task or not on task. This puzzle graphic organizer here is from an intervention that one of my research teams used to work on. The students, when they were on task and doing good work, they would earn puzzle pieces. And when they filled up this puzzle and they would color those in, then they would get to choose a prize from a prize box. And that was a really nice behavioral support to include in the program. You could also use behavioral supports that are a little bit more academic. So for example, UPS check. This is one of the self-regulation strategies or attack strategies that we talked about in the module around problem solving. This UPS check can help students monitor their math behavior to keep them on task. So embedding behavioral supports might be one adaptation or several adaptations that you can make to your intensive intervention. A third adaptation is to increase the dosage. And there's a few ways that we can think about this. One is related to time. Maybe you've been doing intensive intervention for 20 minutes. Perhaps students need 30 minutes or 40 minutes of intensive intervention. Remember, when students are really struggling with math, they're often several grade levels behind in terms of their mathematics knowledge, and we need to help the students catch up on all that mathematics. So that means they need to be doing much more math than they usually are doing. So that might mean increasing the time. It also could be increasing the number of times you meet with the student. So for example, here's our calendar. Maybe you were doing intensive intervention 2 times a week, but perhaps you need to up that to 4 times a week or 3 times a week. So giving students an increased dosage is another way to adapt the intervention. And the other thing we can do with that dosage is increase the number of weeks. So here maybe I initially planned for 10 more weeks of intervention. Perhaps the student needs 16 more weeks or 20 more weeks to really develop foundational math skills. So you could think about increasing the dosage in terms of the amount of time or the number of weeks that you work with the student. Now also in terms of adaptations, we can do a lot of adaptations to the mathematics content. So some of the ways that we can do this is we can change the scope and sequence. This is something that we've looked at in previous modules. Here we've got where the student needs to be. Here's where the student currently is, and we need to fill in this continuum of mathematics learning. You may want to revisit that scope and sequence to figure out what skills does the student have, so where are their strengths, and where does the student have weaknesses, and redo the scope and sequence based on your original idea of where you thought the student would be. Also, in terms of adapting the mathematics content, you may want to think about how you teach problems. So breaking down problems into smaller steps. So here is an example of a word problem. I have to get information from a graph and answer this word problem. So think about all the steps that are involved in solving this problem. The student has to read the problem. They may want to underline the labels to figure out what the problem is about. We want the student to label the graph so that they have an easy time using the numbers from the graph when it comes to problem solving. We want them to identify the schema. We talked about a lot about that in Module 5. We may want them to draw a picture or use a graphic organizer, write an equation, and solve the problem. Now, this is a lot of steps to solve this problem. And you may, within your intensive intervention, you may want to spend an entire day just having students read the problem. Maybe you want to spend 2 days having students read the problem, underline the graph, and label the graph. So kind of doing pre-work to the word problem before ever problem solving. Many students with math difficulty have been taught all of these things at one time, and that's just too much. That's just a lot going on there. So you need to break down problems into smaller steps, and by thinking about each of the steps along the way, saying like, I'm going to spend a day or two identifying schemas and talking about what the schemas mean. I'm going to spend a day or two helping students understand how to use graphic organizers and how to write equations. Because many times the solving part is not the hardest part of a problem like this, like a word problem, but it's putting all of these things in order for the student to solve the problem. Also, in terms of adapting mathematics content, you want to be able to make sure you're focusing on the language of mathematics. We talked about this in a previous module, but making sure that your mathematics language is precise and that you're concise with your definitions of mathematics vocabulary. There's a lot of ways that teachers informalize their math language to make it easier for students, but then that's not helpful for students to connect concepts, to understand concepts, and to understand procedures. So make sure that your math language is both precise and your definitions of math language are concise. By focusing on the math language, have students write different vocabulary terms and definitions in math journals. Students could do Frayer models related to math vocabulary. Many different ways to emphasize the language of mathematics, and just make sure the students are doing that alongside you. Other adaptations is that we need to get the students talking more about math. So here are some prompts where we can get students to think about math. So I might say, tell me how you did this. What were you thinking? How would you teach this? Describe this word problem. When you get students to verbalize their ideas around mathematics, you gain a much better understanding of what they understand and what they don't understand. But it also gives students a time to really make the mathematics their own. So by engaging students in more discourse, and that might be, you're actively doing that, that would be a nice adaptation to your intensive intervention. Another way that we can help with the mathematics content is to provide worked examples. So for example, worked examples, I may provide these two problems right here. One which is solved incorrectly and another which is solved correctly. Give students these worked examples and say, okay, let's talk through each of these problems. What do you think a student was doing when they solved this problem? What do you think a student was doing when they solved this problem? Then maybe students can see, oh, they made a regrouping error or errors. And so then they reflect upon those errors, and then that informs their own practice. Worked examples are something that research say are very helpful for students to see and talk through, but we don't always give students an opportunity to see and talk through worked examples. So giving more worked examples would be another adaptation to your intensive intervention. Other ways that we can help adapt the intervention are to use more three-dimensional representations. So remember, we've been talking about the concrete and the representational and the abstract using our multiple representations here, giving students more opportunities to touch and feel mathematics. I've brought in some concrete manipulatives today. I've got my fraction tiles. These would be a nice manipulative to use when we're talking about fractions. I've got my 2-color counters. These are great for positive and negative integers, for counting, for addition and subtraction, for multiplication and division. And for fractions, they can be used for almost everything. I've also got my base 10 blocks, another concrete manipulative. These are great for whole number operations as well as decimal operations. But perhaps students are having a hard time understanding some of those things. So bring in more concrete objects that students can use to understand mathematics concepts and procedures. Now, not only do we want to maybe add more of the concrete in there, but it might be also nice to add more representational. So more drawings of mathematics, either drawings that the student sees and interprets, or drawings that you do or that the student does. You also have representations, 2-dimensional virtual manipulatives available on so many apps and so many like tablets. Those are really great for students to use as well. So pull more of those in so that students gain a deeper understanding of the mathematics. And also, while you're thinking about adapting the mathematics content, making sure that students understand what's going on in the abstract. Remember, that's with numbers and symbols, but also the words of mathematics. What does EDGE mean? Like, how do I read that word, and what does that tell me about a 3-dimensional figure? Students need a lot of practice with understanding mathematics in the abstract as well. Now, also in addition to with the mathematics content, focus on fact fluency. So many students with math difficulty have limited fact fluency, so make sure you're doing activities. Here's an example of cover, copy, compare. Here's another example with taped problems, another example with flashcards. Make sure that students are practicing fact fluency, I would ask on a daily basis, so that anything that they do with facts is going to increase their fact knowledge, and that's going to make everything in math easier later on. Now, another adaptation around mathematics content is also to focus on other types of fluency. So if students have strong fact fluency, do they have fluency identifying coins and recognizing coin values? Do they have fluency? Here's an example of like writing your multiples out. That helps with understanding of fractions and common denominators. Do students have fluency with adding and subtracting positive and negative integers, multiplying and dividing positive and negative integers? There's all kinds of fluency above and beyond fact fluency. So if fact fluency is well established, think about the other types of fluency you may want to practice with your students. Also, in terms of adapting mathematics content, teaching alternate algorithms. So we looked at this in a previous module, but I'll kind of go over this so we remember this. Remember, we have this standard algorithm. So here, if I'm subtracting 315 minus 96, I'm going to regroup. Oh my gosh, it's been a while since I've written on this board here. I'm going to regroup the 1, and I'm going to regroup that to 15. So 15 minus 6 is 9. And here I have to regroup from the hundreds, so that becomes 2. And I regroup that to the tens column. 10 minus 9 is 1. So 315. Oh, and then I have to subtract 2. Yeah, I did that right. I'm just checking my math there, which is always a good thing to do. When I have 315 minus 96, my answer is 219. Now that's with the standard algorithm. With the partial differences algorithm, I start here. 300 minus nothing is 300. And then if I have 10 minus 9, 10 minus 90, that's going to be negative 80. And then if I have 5 minus 6, that's negative 1. And I'm almost off my board here, but 300 minus 80 minus 1 is 219. And I can also do it with my add up model. So here I'm going to start with 96 and add up to 315. And I'm actually going to do this up here because I need a little bit more space. So I wanted to start with 96 and add up to 315. 96 plus 4 is 100. Now I need to add up to 300. So 100 plus 200 is 300. And then I'm going to add 15 just to make it easy on myself to get to 315. So I add these together. 200 plus 4 plus 15 is 219. So many different ways to solve the same problem. And teaching students these ways, teaching explicitly these ways. Because students may have had difficulty with the standard algorithm, so why don't you try partial differences? If students have much stronger addition knowledge than subtraction knowledge, maybe teaching the add up model, but explicitly teaching students that there's multiple ways to solve the same problem. That could be another adaptation to your intervention. And while I erase my work here, I want you to think about other alternate algorithms that you could use that was some examples for subtraction, but we have alternate algorithms for addition, we have alternate algorithms for multiplication, and we also have alternate algorithms for division. And we've looked at those in one of our previous modules. I believe it was module 6. Now, we can go on here in terms of adapting the mathematics content. In Module 5, we talked about explicit teaching of problem solving. So making you're circling back on those attack strategies and those schemas, and that you're not teaching keywords tied to operations. And then encouraging students that there's many different ways to solve the same problem. I kind of gave an example here. Here's an addition problem solved 2 different ways. Neither one is correct, neither one is incorrect. They're both ways to add. So encouraging students to seek those alternate methods and solutions and be okay with it. I'm not solving the same problem or the problem the same way that all the other students are. So let's take a pause here, and I want you to look at workbook activity number 4. And I want you to think of 3 additional ways that you could adapt mathematics content and describe why each of those ways might be helpful. Go do that, and then I'll see you in a minute. All right, good job on that workbook activity. Now we're going to look at our fifth way to think about adapting intervention for mathematics DBI, and that is to utilize explicit instruction. I hope that this looks really familiar to you, the modeling and the practice with those supporting practice underneath. And I want you to ask yourself, are you actually doing explicit instruction? And are you doing it well? I really hope so. But some things where we see teachers not do so well is maybe teachers are doing modeling without involving the students by asking the right questions and getting those students to frequently respond. And are you doing guided practice? This is one of the things that's often missing. Many times teachers will do modeling and then skip to independent practice. But are you doing problems with your students? Are they seeing you do the same math problems that they're working on? That's what I want you to reflect on. So make sure you're doing explicit instruction and make it really well. So workbook activity number 5 is related to this. I want you to select a lesson that you've taught recently and then take that explicit instruction graphic organizer and think about, are you doing all the things you need to be doing? And then go back and revise that lesson by including one additional component around modeling, guided practice, independent practice, and the supporting practices. In other words, how could you have taught that better? And finally, when we're thinking about adaptations, we want to explicitly teach for transfer. So transfer means that you can solve one problem, perhaps like this, and take that knowledge around this addition problem to transfer it to a more complex problem. This is something in mathematics that a lot of students struggle with. They might do really well here and totally fall apart with this problem, but the ideas and the concepts and the procedures are the same. But unless we explicitly teach for transfer, many students have difficulty with this. So for example, I've got a problem about Marnie. She's been behind the scenes helping us out here. Marnie baked 89 cookies and sold 40 at the bake sale. How many cookies does Marnie have left? Can you take that knowledge and apply it to this problem? Marnie had $89 and spent $40. How much money does Marnie have left? Believe it or not, some students would treat this problem and that problem as different because of these dollar signs, but the underlying construct is the same. And then what happens if Marnie has $89 and spent $40 on shoes, and then how much money will she have after buying the shoes? So here I was asking how much will she have left, and here it's like how much will she have buying the shoes? Same question, but students might think that those are different because they're worded differently. So here you have to explicitly teach for transfer. So here's our list of adaptations that we really want you to think about when we've got those students that are non-responsive to DBI. So we need to implement with greater fidelity, embed behavioral supports. We may increase the dosage. We may adapt the math content. You saw lots of different ways to do that. We want to make sure we're utilizing explicit instruction and explicitly teaching for transfer. Now you're not going to do all of these adaptations at one time. You might pick 2 and focus on those and then see how it goes and then add another one in and drop one out. So, but you got to think about this as that your toolbox. Your toolbox is getting filled with all of these adaptations, and you need to pull out those tools when it's necessary for different students. So we are winding down here. Remember, we've also got you to think about adaptations to make sure that you are doing everything that we know is really helpful for students with math difficulty. So teaching explicit instruction, using those multiple representations, being concise with your language. So those are all around the delivery of instruction. And then including fluency building, problem solving, and a motivation component. These are all strategies that should be embedded within your instructional platform. So speaking of that instructional platform, we kind of go back to our picture here. We've got our instructional platform that's here, and then today we've focused on this intervention adaptation. So how do you adapt the intervention when it's not paying off as much as we would like it to pay off for students with math difficulty? Another way to look at this is based on the article that one of the articles that you've read during this course. And this is here where we put these adaptations into a chart. So here I try a few adaptations, see if they're working, try a few more adaptations, carrying over some from the first iteration of adaptations, check the progress, bring in more adaptations, bring in more adaptations. And so that's why this is a process. It's not just a linear thing from top to bottom, but I'm always progress monitoring those adaptations to determine whether students are responsive or non-responsive. And this is a cycle that we go through with students until they really don't need our help anymore. So our checklist for this part of our module: how do you make adaptations within DBI? Implement with greater fidelity, embed behavioral supports, increase dosage, adapt math content, utilize explicit instruction, and I need to bring in another finger, explicitly teach for transfer. So our final part of this part is to do your discussion board activity. Here I want you to describe how you will make decisions about adaptations within DBI. Are you going to work on your own? Will you work with a team? And what resources do you have available? Good luck!